All right, ladies and gentlemen, uh, here's your snow day assignment. So we're looking at the Newton's second law of motion worksheet, and I'm going to walk you through examples numbers 1 and 2. The due date for this will be when you get back from break by Thursday. Remember, Friday we don't have class due to the extended weekend. So like all of these problems, keep in mind we want to, first step, we want to go through and identify what variables we have and find out what the problem is asking of us. So in example number 1, if an automobile's mass is 750 kilograms, what amount of force is needed to accelerate the automobile by 2.0 meters per second squared? First, right there, it's asking you, what is the amount of force? So that's our question. Okay, we have the amount of force here given to us, and we need to find out what is that amount, which is indicated here. Remember, that's our question. We'll put the question mark there. Just ignore the X here for me, please. And we need to know that force will always be in the unit of the Newton. Okay? That is going to be the case, and the newtons is kilograms times meters per second squared, which is our units that we are starting with. So that's important. You need to make sure that those are the units in your mass, which is given to you here. Your mass needs to be in kilograms, and you need to have your acceleration in meters per second squared, which it is. So there's your A. Okay, so force is equal to mass times acceleration. So let's get rid of that X here as well. F equals ma. And when we multiply 750 times 2.0, we end up with 1,500 kilograms times meters per second squared. Remember, this right here can be simplified to the unit Newton. Now, in our discussion about significant figures, we need to keep in mind that we can only have the number of significant figures in our answer as the smallest value from our given variables. Here we've got 750 kilograms with no decimal place at the end, so the 7 is significant, the 5 is significant, the 0 is not significant. Here we have 2.0. Because there's a decimal place, that trailing 0 does count. So we have 2 does count, and so does the 0 in this case. So with these two, we have two significant figures. And here we've indicated that in our answer, 1,500. Notice that there is no decimal place at the end, so the 1 counts. It is significant. The 5 counts. It is significant. But these zeros do not count. Next, example number 2. In this case, we are giving you the force. The force, as it says here, is 2,000 newtons. So we need to highlight that. So there it is. That's our force. And it's needed to accelerate an automobile by this value. That's your A. And the question is, what is the mass of the automobile? So mass is what we're looking for. So we need to find that. This is our question. And remember, mass is going to be in kilograms for all of the problems like this. So make sure you write that kilograms down as well. Okay? For this type of problem, when we're looking for mass, remember, if we were to move this around, F is equal to ma, right? So I'll do that off to the side here. F is equal to ma. Well, if F is equal to ma, to find m by itself, what we would need to do is divide both sides by a. A is going to cross out on this side. So M is equal to F over A. Now keep in mind, in terms of our units here, we would say that would be equal to saying kilograms is equal to newtons divided by meters per second squared. Sorry for my writing here, hard to do. And if we remember, the newton was this value from the previous problem, kilograms times meters per second squared. So if we divide kilograms times meters per second squared by meters per second squared, this would cross off. In other words, we could rewrite this as kilograms is equal to, kilograms is equal to kilograms times meters per second squared divided by meters per second squared. Okay, and when we do that, that would mean, and I'm going to change colors here so we can do this, that would mean that my meters per second squared crosses off and kilograms would be equal to kilograms. So we now plug our numbers into our equation and we get 2,000 divided by 2, and that equals 1,000 with one significant figure because we only have one significant figure in our variables. Our answer can only have one sig fig, and the units, remember, is kilograms. If you have questions, and we do have snow tomorrow, keep in mind I am still here. If you need me, please contact me through Schoology, and I will do my best to help you. Thank you, and have a good rest of your day.